Within the last few years, developments in mechanical tunneling have proceeded rapidly because of the increasing global demands for cities, federal states, and nations which concern the extension of transport routes. The special requirement for the construction of the Nafsut Tunnel, northeast of Kermanshah in Iran, have led to a so-called double shield TBM with a diameter of 6.73 meters. The TBM will drive an approximately 25.7 kilometer-long freshwater irrigation tunnel to allow the cultivation of further agricultural surfaces. The following computer animation illustrates the functional principle of a double shield TBM. Tunneling is carried out via a shield, which operates as advancing protection unit to secure the tunnel wall prior to tunnel lining. In the rear of the tunnel boring machine, in the tail skin, reinforced concrete elements, called segments, are installed. They provide the final one-layer tunnel lining, which secures the surrounding tunnel wall and protects the inside of the TBM and the staff working in that area. The overall system of the double shield TBM, deployed in Dasht-e-Zahab, has a diameter of 6.73 meters and measures 185 meters in length. The double shield TBM owes its name to its special design. A telescopic front shield is mounted on the front area of the TBM. The TBM area behind the shield is not moved during tunneling. The reaction forces which occur during tunneling, such as torque and longitudinal forces, are transmitted to the tunnel wall by extended gripper shoes, which are located in the intermediate section of the tunnel boring machine. The separated force distribution design allows installation of segments during tunneling, in contrast to common tunneling methods. After completion of one thrust cycle, the gripper shoes are retracted and the rear shield is pushed forward against the front shield. The displacement phase only lasts a few minutes. After that, the next tunneling cycle can start. Continuous advance, which means that the boring process can be carried out parallel to segment installation, guarantees high performance rates. The TBM can only drive in continuous mode in undisturbed geological formations, since the gripper shoes use the tunnel wall as support. The telescopic front shield can, therefore, only be extended in stable rock formations. Once the double shield enters fault zones, the telescopic front shield is retracted. Now the entire tunnel boring machine only advances with the help of the auxiliary thrust cylinders, which are pushed against the tunnel lining. This type of advance is described as a non-continuous advance, since an advance with the auxiliary thrust cylinders is only possible after completion of one segment ring, similar to a conventional shield. In fractured rock formations, this operating mode provides optimum safety. The operating mode allows adapting the machine to geological conditions and to achieve optimum performance rates in varying conditions. The sophisticated double shield technology of continuous advance requires additional detailed solutions with regard to design and mechanics. The cutter head is driven by circumferentially arranged frequency-controlled electrical motors. Each individual motor gear is engaged in the toothed ring gear of the main bearing. The installed drive power is 2100 kilowatts. The transmission of the torsion torque generated by the tunneling operations and the required thrust forces between front and gripper shield is particularly important for double shield design. The main thrust cylinders generate the longitudinal thrust forces, which connect the steel structure of the front shield with the gripper shield. The torsional forces generated by the tunneling operations are distributed to the steel structure of the gripper shield through two torque reaction cylinders. The torque reaction cylinders compensate the relative motion between the front and gripper shield. The gripper shoes are floating relative to the machine body. Two heavy hydraulic cylinders mounted between both gripper shoes force the gripper shoes out of the rear shield against the tunnel wall. The thrust forces and torsional forces are transmitted in the contact zones between gripper shield and gripper shoes. This allows a friction-locked connection and guarantees the final deflection of the forces. The cutter head of the double shield TBM is equipped with special hard rock cutting tools, 42 steel cutter discs 17 inches in diameter, which are installed and supported on the cutter head, roll on the tunnel face due to cutter head rotation. Each disc is pushed against the tunnel face with 27 tons, thus breaking off the rock. The excavated material, so-called chips, fall into the tunnel invert. The spoil is taken up through 6 muck openings with buckets and lifted towards the top due to rotation. From here, the excavated material slides across chutes into the rear of the cutter head center. There it is discharged onto the conveyor belt through the muck ring. The actual lining operations in the excavated tunnel are carried out behind the shield. A complete segment ring consists of 4 reinforced concrete elements, called segments. The segments are turned by 90 degrees on the segment feeder and driven to the erector. The erector is controlled from a portable control panel with direct operator oversight. The segments are lifted from the segment feeder by means of a mechanical pickup plate. The auxiliary thrust cylinders are retracted prior to the installation of the next segment to allow a segment positioning in the next space. The next invert segment is installed and braced against the entire TBM system due to the immediate thrust of the auxiliary cylinders. After the installation of the invert segment and the top segment, the other segments are installed, displaced by half a segment width. The segment edges provide a self-centering installation, precise to the millimeter. Now ring build is completed, and the tunnel is growing ring after ring. Heron Connect, the technological leader in mechanical tunneling, has the know-how and experience to carry out any tunneling project. The company from Germany's southwest is the only provider worldwide that offers and markets the whole range of mechanical tunnel boring machines ranging between 100 millimeters and more than 15 meters in diameter. Contributing to Heron Connect's success, more than 25 years of experience and a worldwide service network make Heron Connect a competent partner.